I do yell towards people, I suppose. Never yell at people. All right, so if you're following along at home, and hopefully you are, Jenna! Angle 1 and angle 2 are complementary. That's what we wrote down. We chose orange because we didn't have yellow, and we chose dark blue because it was a joke, and then we chose light green because why would we choose a color we can see? So I'm going to label our diagram with those beautiful colors. All right, so our goal is to get 1 and 3 in the same equation, in the same room, if you will. We have stuff that have 1 and 2 together and 2 and 3 together, but not 1 and 3 together, right? But we can see what they have in common. Angle 2. So we said, when I used to have a not smartphone, I used to like pull it out and just like throw it on the ground. But I won't do that anymore. All right, so these guys, they mean that these angles add up to 90. So let's write that. Measure of angle 1. Tell me if you can't see. Measure of angle 2. Add up to 90. And we know that by definition, right? Ta-da! All right. And we also know that measure of angle 2 and measure of angle 3 add up to 90 by the same dumb thing. That's a 90 right there. And those are both by definition. Cool. So, what do these two equations have in common? How are we going to get 1 and 3 together? Substitution. Yeah, that's typically how it's done. But like, what do they have in common?
2.
Angle 2. You're right. You're right. You're absolutely right. And what we can do is we can get angle 2 on its own by moving over angle 1, right? And we get angle 2 equals 90 minus angle 1, and we can take that 90 minus angle 1 and put it here, right? Does everybody see that for the most part? I can rewrite that by moving angle 1 over, and so I get angle 2 equals 90 minus angle 1, and I take that 90 minus angle 1 and plug it in for 2, right? That is true. However, they also have something else in common. Yeah?
Did we use the transitive property to do this one?
Yeah. Kind of. Transitive property, if you haven't kind of picked up on it, is really just like advanced substitution. It's just like really fast substitution that skips a bunch of steps. Because we don't have a bunch of things that we're going to be doing, I mean, I don't see how we would do like a bunch of substitutions all at once with transitive property. Maybe you do, and you can explain it. But I'm going to do one substitution that I think you're really going to like, and I think it's going to do what you're thinking. So you tell me if it doesn't, okay? So not only do they have angle 2 in common, but what else do they have in common? Yeah?
They're both complementary.
Yeah, they're both complementary. In other words, they both equal 90, right? So if this equals 90 and that equals 90, don't this and that equal each other?
Mm-hmm.
So check this out. We didn't do this yesterday. We did it the other way. We did the move stuff around and then switch out for 2. I'm going to show you a different way of doing it. So taking these guys and putting them together. So I know that the measure of angle 1 plus the measure of angle 2 should equal the measure of angle 2 plus the measure of angle 3. Right? They both equal 90, so they equal each other. Right? It's a little less messy than having to move the 1 over and then switch stuff in, right? And now what do you notice? 1 and 3 are together. Just there's extra people in the room, so we got to remove them. How do we get rid of them? Yeah, right? If we subtract angle 2 from this side, notice that the angle 2 on this side will also go away. Right, so let's do subtraction property. And we're almost home free. So this is by, we did that by substitution, the first one, right? Subs. And this is by the subtraction property, SUBT. And then if we know that the angles are equal, or the measures are equal for the angles, then we know that the angles are congruent. So that's our last step to write that. We get that for free. If you feel weird not writing a reason, just put it there for. There's some things in here we are going to not have to back up. By definition, I suppose you could say that if the measures of the angles are equal, then they are also congruent. Normally, congruency means that everything is the same, but angles only have one thing about them. They're measured, right? If we're trying to prove that shapes are congruent, well, there's lots of things. They have sides, they have angles, they have all this stuff, right? So we got to check it all. But angles are just their measures, so therefore they're congruent. How do you feel about that one? Yeah, it is if you see it, right? The hard part is right here, seeing the connections, right? Writing that they're complementary and what that means, not so bad. You just need to know it, right? And then being able to connect them is the hard part. After that, the math takes care of it, right? So Jericho, was that what you were thinking?
Kind of.
How did you do it?
I was kind of confused, so I just wrote transitive property equality and then like wrote that one is congruent to 3.
Okay.
So, yep.
Let me show you something. So, if you have something like this, let's say we have, can you see me? All right. If we have something like this, angle 1 is congruent to angle 3, is congruent to angle 5, is congruent to angle 7, okay? Transitive property allows you to say, if 1 is 3 and 3 is 5 and 5 is 7, then I must know that 1 is 7. That's kind of transitive property. Do you see how I'd have to do a bunch of substitutions otherwise? I'd have to be like, look, 1 is 3, so I'll write it as 3. Oh, look, 3 is 5, so I'll write it as 5. 5 is 7, so I'll write it as 7. Oh, therefore 1 is 7, right? Transitive property lets you cut these guys out and just go straight to the thing. For this guy, I don't think we really have that, right? At least from here, right? From above my fingers. Once we get here, we kind of have something like that, right? But at that point, we're just doing subtraction, okay? But not a bad idea. Transitive property is one of those things where it's so much fun and it's so quick that it's tempting to use it at all times. I'm going to be honest. Most of the time in here, we'll be doing substitution instead, right? We won't have a bunch of things in a row like that we have to jump through. Typically, we won't have that many things to talk about, right? There's only a couple angles here. So that was 3. Again, we could have done it another way, and I've mentioned this a couple times now, but I'll just write it out now. So the other way you could have done it is you could have taken either the top or the bottom. I'll take the top and rewritten it like this. Measure of angle 2 equals 90 degrees minus measure of angle 1. Right? Does everybody see how I moved that over now? If you didn't before, right? I subtracted from both sides, so that's subtraction property equality. And then if this is angle 2, all this stuff is angle 2, then I can take that and plug it in here. So I get 90 minus angle 1 plus angle 3 equals 90. Subtract 90 from both sides, that goes away. Move the 1 over, and I get angle 3 equals angle 1. Then we do symmetry, flip them, something like that.
Like this way.
I think this way is nicer too. I try to go with the way you see it, and Noah saw the 90s, so that was pretty good. All right. So number 4, it's really the same dumb thing. It's just we're talking about supplementary. We have an amendment, if you weren't here the other day, right? This should read angle 1 is congruent to angle 4. So given this information, how do we prove it, right? Well, again, our goal is to get to here. Angle 2 and angle 3 in the same equation. Hopefully they'll be congruent, right? That's the whole point. 1 and 2 are supplementary, so they're going to be together in some way, right? We'll talk about what supplementary means in a second. We've got 1 and 4 together. We've got 3 and 4 together, but we don't have any 2 and 3s together, so we have to do some work to get them in the same room. So let's talk about what supplementary means. What does supplementary mean? Yeah, so the 2 sum together, right? Not you can't call a single angle supplementary, right? It's about the relationship between 2 things. So the 2 angles that we're talking about, if they're supplementary, then the relationship is that they sum to 180, right? So angle 1. Light blue for angle 1. So wherever I see an angle 1, I'll make sure it's light blue. All right, so angle 1. Noah! What about angle 2? Red. I save red for the swag boxes. Green it is. So angle 1 and angle 2 are sup. We're also given that angle 1, again, same color, is congruent to angle 4. What color we want angle 4 to be, Michaela? Pink. Much better choice this time. And then we know that angle 3, which we have not colored in yet. What color would you like angle 3 to be? purple. That's good? Not paying attention. All right. Angle 3. And angle 4 is supplementary. Okay, so that's what we're given. Let's take that information and make some equations, right? Because we need some equations at some point, right? So 1 and 2 are supplementary. We said that means they sum to 180, and that's correct. So I'll write that. Again, do I know if that's going to help me or not? Not really, but at least it gets me some equations. And that's always good. Right? And we know that by definition. Right, that's the definition of supplementary. So what do they have in common? Well, unlike the last one, we don't have an angle in common between the two, right? Not really. You might be clever and be like, oh, look, 3 and 4 are the same. That's true. Or not 3 and 4, sorry, 1 and 4. My bad. Ignore that. No, go away. 1 and 4 are the same. So we do the substitution and call that angle 4 right here, right? We'd have angle 4 plus angle 2 equals 180, and then we could do what we almost did last time, right? We can rearrange it to get one of those angles on its own and then switch them out, right? So once that's an angle 4, we move that over. We get angle 4 equals 180 minus angle 2, and then we plug that in for angle 4, and we got 2 and 3 together, right? Which is our goal. But there's something else they have in common. 180, right? So these guys must equal those guys. Do you see it? Okay, cool. So let's write that. Measure of angle 1 plus the measure of angle 2 equals, not 180, we're going to switch that out for measure of angle 3 plus the measure of angle 4. And we did that by substitution. Right? What did we switch out? Well, we switched out 180 here for all this crap. And now everybody's at the party. You got every single angle in the same room. The question is which ones are actually congruent. So what do we do now? We've got 2 and 3 in the same equation, but we have got extra pieces here. How do we get rid of 1 and 4? Subtraction property, right? Because if I subtract angle 1 to this side, angle 4 minus angle 1 will be 0. Now how do we know that? Well, because angle 1 and angle 4 are the same thing. Now, if you didn't remember that, or if you didn't see it, that makes sense because that was not a very thorough proof, right? It assumes that people remember what we're given, and we don't. We always forget. So what we're going to do first is substitute. That way we have, like, if I switch out that angle 1 for an angle 4, that way when I subtract it, I've got angle 4 minus angle 4. And anybody would be like, oh yeah, that's 0, right? So let's switch out that angle 1 for an angle 4. So measure of angle 4 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And again, that's by subs. Don't forget your S. What? We did. We switched 1 and 4.
So why did you want on the other side? On the bottom?
Oh, I get what you're saying. Okay, so what we really are doing is we're not switching these two. We're not flopping them, right? What we're saying is that 1 and 4 are the same thing. So wherever I see angle 1, I can write it as angle 4 if I want. And so I did. And the reason for that is because I'm going to subtract it. And when I subtract it, see how these are the same? That way it goes away. Now you're clever and know that 1 and 4, because they're the same, I could subtract it right there and it would go away, right? But not everybody's going to see that. So we're going to make it obvious by showing that, look, it's going to be angle 4 minus angle 4. That's definitely a 0, right? Definitely. Because angle 1 being subtracted from angle 4 only gets you 0 if they're the same thing. And we have to remember that they are, right? So we're just substituting that way we can easily show, look, it's going to go away, right? Good question. All right, so I'm going to subtract angle 4 from both sides, and what happens is I get this. Measure of angle 2 equals the measure of angle 3. And that was by subtraction, S-U-B-T. And then our last step is to show that angle 2 is congruent to angle 3. Which is what they wanted, right? 2, then 3, in that order. Yep. Swag box. Done. All right, walking through it in slow-mo, just in case you were a little lost. Again, don't try to memorize the individual stuff. Think of the concepts. Right? First of all, we wrote what we had given to us. This guy, right? Next, we said, well, what does this mean? Which is like the only question. Supplementaries add up to 180. That's by definition. I know it when I see it. And then we said, look, that means they equal each other because they both share the 180. So we substituted. Then that tells us, it tells us that 1 and 4 are the same, so I switched those out. That way when I subtract them, 2 and 3 are on their own. How you feel? Better than yesterday? Yeah, pretty good. Okay. Turn the page. Number 5. All right, so again, we had to add in some extra information here. A, B, and C are collinear. Thank you. A was here. B was there. C was there. And this is a lot of information to say something really simple. There's D, B, and F. I skipped E because E is for idiots. Starts with an I. All right, so when we say something's collinear, right, those points are collinear, it means they rest on a line. So they gave us that it's collinear, meaning that A, B, C, the figure, is a line, right? That's the information we're going to pull out of that. Why do we need to know it's a line? Because what we're going to use is linear pair theorem. And remember, linear pairs are angles that sit on a line. So just because I draw something like this doesn't mean those are both lines, right? I could have a little bit of a bend here, but I just drew it poorly. Does that make sense? So we need to be able to know that those are in fact lines here. And we do know they're lines because they're collinear. A, B, and C are all on a line is what it says. Same thing with D, B, and F. Is that cool? It seems kind of silly, and at some point we'll just be like trusting our diagrams that, look, it looks like a line, so it's a line. But right now we got to prove it. So what we're going to do is we're going to say, given ABC collinear, and DBF collinear. We have a lot to prove here, but it actually works out kind of nicely. A couple things to prove: that, and that. All right, let's assign colors for our angles so we can keep things organized. Angle 1. Bo, what's 1 going to be? What color?
Green.
Green. So angle 1 is green. No yawning in math class. What color would you like angle 2 to be?
Orange.
Orange. Good color. Oh, and I said angle 2, not angle 3, so we'll go with angle 2. 2 is orange. Shh, no talking. Angle 4.
Brown.
Brown it is.
That's the cool picture.
Why are you hating on the color brown? All right, so now we got colors to keep things organized so you know what I'm talking about, right, based on the diagram. Again, I encourage you to get some pens. I only have so many, and I can only lend out so many during an exam. Let's do this. So if they're collinear, then we know what about ABC, the figure. ABC is a what? A line, right? I know, a lot of this seems pretty obvious. ABC is a line, and we also know that DBF is a line, right? Now, why do you think we know that? We haven't defined a line in here, because, like, at some point the madness has to stop, right? But the definition of a line would be that all the points are collinear, right? The points on a line. Something like that. So, by definition. If ABC are collinear and DBF are collinear, then ABC and DBF must be lines. Cool. So we know those are lines. Now, why is that useful? Well, we want to prove angle 1 and angle 3 are congruent. Check it out. Those are vertical angles, right? They're across from each other, scissor theorem. So vertical angle theorem says that those have to be congruent. Yay, we win! But I told you yesterday, we're not going to use vertical angle theorem yet, right? So what we're going to do is we're going to do the same thing that I did to prove vertical angle theorem in the first place. What we're going to do is we're going to focus on angle 1 and angle 2. What do we know about angle 1 and angle 2? They're supplementary. How do you know they're supplementary? Because they form a straight line, which is a straight angle, right? In other words, those two angles are a what? Everybody always forgets this one. We have a theorem named after it. 1 and 2 are what kind of angles? They're supplementary. That's right. The theorem says they have to be. A what? They are adjacent. They are next to each other, but we have a special name for them when they also sit on a line. What line? What word do we always use when we talk about lines? Linear. So they're a linear pair. Remember that? So 1 and 2 are a linear pair by definition because there's two angles sitting on a line. Pair meaning two, linear meaning line, right? Two angles sitting on a line, so they're a linear pair by definition. Linear pair theorem says if they're a linear pair, then they're supplementary. We know what supplementary means. It means they add up to 180. So that's what I'm going to write. Okay? So I know angle 1 and angle 2. Are a linear pair. And I know that by definition. Right? Two angles sitting on a line. Pair means two. Linear means line. Pretty self-explanatory. And again, I've already proven that it is actually sitting on a line. APC is a line. DBF is a line. If they're a linear pair theorem says that they're supplementary, right? So now I can write angle 1 and angle 2 supplementary. And you're wishing we could just skip to the adds up to 180 part. But we can't yet. Are sup. And we know that by linear, I'll write it out. Linear pair theorem. It's the theorem that says if we're looking at a linear pair, then they must be supplementary. And if they're supplementary, what does that mean? Yeah, the thing you really want, right? The measure of angle 1 plus the measure of angle 2 is going to get us 180, right? And that's by def, right? Definition of supplementary. Cool. Now, we know 1 and 2 add up to 180. What about 2 and 3? Because remember, our goal here is to get 1 and 3 together, so I have an equation with 1 in it, right? If I can write something about 2 and 3, then I've got 2 and 3 together, and I can cut out the middleman type of deal, right? Kind of like transitive property. So what do we know about angle 2 and angle 3? I'll give you a hint. What do you see? What do you notice? They're on a line. Two angles on a line is a linear pair. Linear pair by definition, right? Linear pair theorem says they must be supplementary, and if they're supplementary, they add up to 180. Ah, okay. So it's the same dumb crap we just did, but with 2 and 3. So you know what we're going to do? You're going to love this. You're going to love it. By similar logic, this is your favorite. Skip all of that. Write measure of angle 2 plus measure of angle 3 adds up to 180. Yay! Isn't that nice? Same dumb argument, just different angles, right? Save yourself some time. Keep both eyes open in my class, please. All right. Angle 2 and angle 3 add up to 180. Yay! So now what do we know? Well, they have 2 in common. We can move stuff around and switch them out. Yeah, but, like, we could. What else could we do? What else do they have in common? They both add up to 180. So let's write that. Measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus the measure of angle 3. That was by substitution. Does this feel familiar? They both add up to 180, so we put them together. It's the last thing we've been doing, right? The last two. Except one of them was 90. All right, and now, subtraction property, yeah? You feeling it from here? Okay, I'm going to save time and pretend we know all that stuff. You would write it for an exam. but we know what's going to happen next, right? They go away and we get 1 is 3, right? So yada, yada, yada. We get angle 1 is congruent to angle 3, which is what we wanted. Swag box. Is that cool? All right, now, we also need to prove 2 and 4 are the same. Look at 2 and 4. They're vertical angles, aren't they? Didn't we just do a thing with vertical angles?
Yeah.
So check it out. By similar logic, angle 2 is congruent. Whoops, that's a 2 there. Is congruent to angle 4. Swag box. Be the exact same thing, just with the angles, the angle names changed, right? So that's done. We also need to prove that 1 and 2 are supplementary. Have we done that already? Right here. There's the proof for 1 and 2 are supplementary. That's it. If you were to write it all over again, you would start from here and go there. It would be a very short proof, right? So we already did it. Now we need to prove that 3 and 4 are supplementary. We proved 1 and 2. Wouldn't 3 and 4 have the exact same argument, just different angle names? So by similar logic, angle 3 and angle 4 are supplementary. So let's write that. Angle 3 and angle 4, which is brown, are sup. Done. How about them apples? Bam, bam, bam. Wham, bam, thank you, ma'am. Now, when we write this out, like, with words and not just, like, jumping around and all this stuff, like, you'd have to make it flow a little bit better, right? You can't just be like, arrow, right? But for now, this is okay. We're going to work on writing next week. This is basically a written proof, though. Like, you guys are scared of that, I think, the whole writing part. But, like, if you can do this, or if you're feeling like you can do about 50 to 75% of this right now, wait a couple more weeks, you'll probably be better at it. That's a written proof. This is basically it. When people don't do a written proof, it looks something like this.
Oh, goodness.
Like that. And then it's like, oh. Like, that's the nonsense that they do. It's like this box chart. And, like, most of the time when we teach it to you in geometry, you get, like, that information. And they're like, fill in the boxes. Which basically turns into a do you know your definitions, right? Because it'll be like linear pair theorem. And it'll be like, fill in the thing. And it'll be like, oh, well, linear pair theorem says that they add up to 180. So which ones look like they add up to 180? Oh, I'll just write that down. You don't have to actually know your crap. And again, they give you half the information, which is like the whole point of proof is to like do your own thing and to come up with your own strategy and learn how to argue. Like, imagine if you joined debate team or like speech and they were like, okay, you need to argue a point, but every like 5 seconds we're going to whisper what you're supposed to say and then you're going to fill in the blank. We'll call it learning. And not only will we make it a half semester class, we'll make it an entire year and call it geometry, right? What a waste of everyone's time. And you have to memorize all those definitions, right? Go away. Hi, Jenna. Hi, Chloe.
Jared, is that your opinion?
Well done. Hi, Lainey. Who else is gone? I said hi to Chloe. I won't say it again. I won't say it again. Go away.